Hello, welcome to the chapter on conics study guide. We're going to go ahead and get started with number 1, where it says prove that the graph of the equation is a parabola and find its vertex, focus, and directrix. In order to do that, we need to complete the square with this equation so that we can identify the vertex and the p-value so that we can find the focus and directrix. Let's go ahead and get started. Okay, first isolate your x terms to one side. Then what I did is I factored out the 3 so that my term with the x squared has a coefficient of 1. And then I take half of this b value next to the x, raise it to the power 2. Half of negative 2 to the power 2 is 1, so I add in a 1 there. Now I have to balance my equations, so that means I'm going to not add a 1 on the right, but add a 3. Because if we were to multiply in the 3, we would really be changing the left-hand side by 3. Okay, so on the left, I have factored my perfect square trinomial, and I have 2 of the same binomial, so we have x minus 1 squared. We've added 3, and what we need to do from here is factor out a 4 on the right so we can identify the vertex. Okay, so after factoring out the 4, we now can identify the vertex. By the way, over here on the right, I've shown you my thought process as I factored out the 4. How am I going to get that k value? So finally, what we need to do is put this in the form of the conic parabola. So I have to divide by 3 on both sides. So now that I have the form of a conic parabola, I can find my hk and my p value. So now I have the ability to find my focus and my directrix because I have P. I think it's best to draw an illustration of what the graph would look like, and that will help us better understand the placement of the focus and directrix. So we have a parabola faced up, which means that our focus is going to be placed within the cup of the parabola. So what I want to do is I want to add on to my y value of my vertex to find the point of the focus. Okay, so I've found the focus point by adding 1/3 onto 3 over 2. That brings me to 11 over 6, which is 1 5/6, which is very, very close to 2. So this is where my focus is located. I need to find my vertex by subtracting the p-value from 3 over 2. So I've subtracted 1/3 from my y value of my vertex to find 1 and 1/3, which means that my directrix is right here, right in back of the vertex of my parabola. Okay, let's move on to problem number 2. Let's find the equation of a parabola on its side with the vertex at 0, 2 and a point on the parabola at -6, -4. Okay, we know several things based off of this here. Let's get a picture and an equation. Okay, so here's the equation, and here we have the 2 points based off the given information. I know that my parabola is on its side, and so it's going to have to go through those 2 points there, and that means that based off that picture, my p-value is going to be negative. Well, we have the h and the k value. That's the vertex. All we need to find is the p-value. We have a point on the parabola, an x, y, and hk, so we need to plug everything in order to find that p-value. So at this point here, I've plugged everything in, and it's just a matter of solving for P. Okay, now that I have P, I simply just need to plug in HK along with P to find the equation. So here we have the equation. If I wanted to, if I wasn't feeling sure about this, I could solve for Y and plug this into my graphing calculator in order to be sure of myself. I'm not going to do that right now. I'm going to move on to problem 3. We want to find the parabolic equation with this given information. I think the best thing to do is to graph the given information and that will help us to have a better understanding of the parabolic equation. Okay, so here we have a directrix at x equals 5 and a focus at 2, -3. This tells me that I have a parabola that is on its side faced towards the -x direction. That tells me that my equation is going to be this form here. So what I need to do is I need to figure out the hk value and the p value. And we can find that with this info here. Let's go ahead and figure out the distance from the focus to the directrix. The midpoint of that will be the vertex of the parabola. Okay, so what I've done here is I've found that the distance from 2 to 5 is 3, and half of that is 3 over 2. So I've taken the x value of the focus and added 3 over 2 onto it to find my vertex. The vertex is going to be at 7 over 2, comma, -3, which means that I go to 3.5 and -3 to place my vertex. Now the p-value, remember the p-value is the distance from the focus to the vertex, or from the vertex to the directrix. And in this case here, it's 3 over 2, but because we're faced towards the -x direction, we're going to have a negative p-value. That means that p is equal to -3 over 2. We have hk and we have p. We simply need to plug that in to the equation of our parabola to find that equation. Okay, let's do that. Okay, so we've plugged everything in, we found the equation. Let's move on to the next problem. Find the vertex, focus, directrix, and graph. Okay, so first thing that we need to do is put this in the form of the conic parabola and then identify vertex and p-value so that we can identify the focus and directrix. Okay, so I found the vertex and I found the p-value. And what I need to do from here is let's go ahead and graph. Let's look at the picture and then identify the focus and directrix. Okay, so here we have the parabola on its side facing to the -x direction because the p-value is negative and the y is squared. So let's figure out the directrix. So let's figure out this directrix here. We're going to add or subtract the p-value onto the x value of the vertex. And so that gives us we have 2 over 2 here. That means that we're going to have a 5 over 2 for the directrix, which means that we have a directrix at x equals 2.5. Let's figure out the focus. Okay, so I've added the p-value onto the x value of the vertex to find that focus point. And it's right here at -1, -1/2, 1. And that gives me everything I need. Let's go ahead and move on to the last problem here. The mirror of a flashlight, last parabola problem anyway. The mirror of a flashlight is a paraboloid of revolution. Its diameter is 6 centimeters and depth is 2 centimeters. How far from the vertex should the filament of the light bulb be placed for the flashlight to have its beam run parallel to the axis of its mirror? This means that we need to place the focus, the bulb at the focus. Let's get a picture. Okay, so here I have the flashlight drawn on the left over here, and we want to place the bulb at the focus. And so what I've done is I've taken that three-dimensional paraboloid of revolution and I've placed the parabola into the XY system to identify some points on the parabola. What that is going to enable me to do is to figure out the p-value by relating this particular parabola to x squared equals 4py. I can plug into x and y and solve for the p-value. So solving for p gives us 9 over 8, which means that we need to place the bulb 1 1/8 centimeter from the vertex. Let's move on to problems that are not dealing with parabolas. Let's find the equation of the ellipse in standard form. This means that we need to complete the square. So we're going to complete the square with x and y. Let's go ahead and group the x's with the x's, the y's with the y's. Pull that 44 on the right side. Okay, so now I want to complete the square, and in order to do so, my x squared has to have a coefficient of 1, my y squared needs to have a coefficient of 1. So I need to factor out my 12 from my x terms and my 4 from my y terms, my negative 4 from my y terms actually. So we've factored out, and now we have the ability to complete the square. Half of negative 6 to the power of 2 is a 9. I need to add in 9 there. I haven't really changed the left side by a 9. I've actually changed by a 12 times 9, which is 108. So I need to add 108 to the right side over here. And then over here we have half of 4 is 2 to the power of 2 is 4. We're adding in a 4 there. And we're not really adding in a 4, we're actually subtracting 16. So I need to balance that out by subtracting 16 to the right side. Let's go ahead and see what this gives us. Okay, so we've factored the perfect square trinomials, gotten two of the same binomials, and now we have a 48 on the right, and we have to divide both sides by 48 to find the equation. Okay, so here we have our equation, and something should tell you that this doesn't look exactly like an ellipse, right? This looks a little bit more like a hyperbola. We have a minus there, so I found a typo in my study guide. This is a hyperbola because of the minus sign there. All right. Let's go ahead and jump to the next problem. We want to find an ellipse that has these foci points with a minor axis of length 6. Find the equation in standard form. I think the best thing to do is get a visual of what's going on and then come up with that equation. So I've plotted my focal points, and what that tells me is where the center of the ellipse is. We look at the distance from one end to the other, and that's a distance of 10, and halfway is going to tell us the center of our hyperbola. Okay, I said hyperbola again. Ellipse. Okay, so I have added on 5, which is half of the distance, to one of the focal points, and that's giving me my center. I'm going to find my minor axis. Well, the minor axis has a length of 6. Half of that is 3. So that means that since b is 3, b squared is 9. I need to figure out what my a squared is. The distance from the center to one of the focal points represents the c value. C is equal to 5. That means that c squared is equal to 25. I have b squared and c squared, so I can find a squared. A squared equals b squared plus c squared, and that means that our a squared is 34, and we have everything that we need for the equation. So the a squared is underneath the x squared because the major axis is parallel to the x-axis, and the minor axis is parallel to the y-axis.